Okay, today we're going to complete the square. The square root property. We're going to use the square root property first to solve a few quadratic equations where it's a perfect square trinomial equals a constant. You should recognize this as a perfect square trinomial because 81 is a perfect square, 9 times 9 is 81, and 9 plus 9 is 18. That's how you can tell it's a perfect square. So this factors to x minus 9 quantity squared, and that would equal 49. You then can take the square root of both sides, and you have plus or minus the square root of 49. My pen's sticking. Okay, and then, of course, that's plus or minus 7. So now I'm going to say x is equal to, and I'm going to add 9. 9, I'd like you to put that first, plus or minus 7. And then I finish it off by evaluating those two exact solutions. So x would be 16, or x is 2. The second one factors to a perfect square trinomial. It is a perfect square trinomial. 10 times 10 is 100, and 10 plus 10 is 20. So this will be factored to x plus 10 quantity squared is equal to 64. Taking the square root of both sides gives us positive or negative 8. And then subtracting 10, I'm going to start with it, negative 10 plus or minus 8. I'll do negative 10 plus 8 to get the first solution of negative 2, and negative 10 minus 8 to get the second solution of negative 18. Okay, we've done the square root property before. So now this one is a perfect square trinomial. It factors to x plus 1 quantity squared. And then we take the square root. Square root of 16 is 4, so we got plus or minus 4. Next, we subtract 1. Negative 1 plus or minus 4. And then we're going to have to divide that by 2. Okay, so I'm going to do with that in my head. Negative 1 plus 4 would be 3. So one of the answers is 3/2. Negative 1 minus 4 would be negative 5, and divide that by 2 would be negative 5/2. Okay. Am I going too fast there? Want to slow down a little bit, or are we okay? Pretty good? Okay. Back to the next one, perfect square trinomial. 25 is a perfect square, 16 a perfect square. Square root of 25 is 5, square root of 16 is 4, 5 times 4 is 20, 20 doubled is 40, that's why it's a perfect square trinomial. So this factors to 5x plus 4 quantity squared equals 28. Take the square root of 28, positive or negative, simplify the radical. I'm going to subtract 4 and simplify the radical. So that's 7 times 4, so 2 root 7. That's an x. That looks terrible, so let me fix that. Alrighty, then you divide everything by 5. You can just put negative 4 plus or minus 2 root 7 all over 5. Or you could separate it into two pieces. And I am allowing you to write the two solutions kind of together like that if it's not simplifiable. All right, as long as you know how to separate them. So now we're going to be completing the square. So we're going to be putting it into a perfect square trinomial form. Now, here's a perfect square trinomial, x plus 2x plus 1. Why is that a perfect square? Because it factors to x plus 1 quantity squared, because 1 times x doubled is 2x. Whatever you have in here doubled is 2x. Oh, sorry. Yes, of course. And I did forget to write x squared. Sorry. Yes, thank you, Scott. This is a perfect square trinomial. Okay, now, What I'm trying to get you to see is where this came from. You see how when you factor this, that this number is half of the number here? Just like I said, when you do this and FOIL it out, this times this doubled is your middle term. Okay, and the last one times itself is the end. So the process of completing the square is, if you only know this part, you look at just this part right here, you need to take half of the number in front of the x term. You need to have a coefficient of 1 on the x squared term. You take half the b value and square it, and that goes at the end. Okay? And then it will factor to x plus half of b quantity squared. So if we wanted to complete the square on this, okay, remember the last term of the trinomial will be half of the b term squared. So here's your b, okay? Half of 6 squared will go here to make it a perfect square trinomial. Okay, now what does that equal? Well, half of 6 is 3, and 3 squared is 9, and then this thing would factor to x plus 3 quantity squared. Okay? What number would go into number 6? Well, the b term is 16, and I'm going to ignore, guys, because you notice that we're squaring whatever we put here. Okay? Whatever we put here, now, you got to make sure this sign is always going to match. The one right here is going to match all the way through. All right? I don't worry about it being negative when I put it here. You can if you want to think about the fact that when we're going to factor it, it's going to be x minus 8. Do you see what I'm getting at? This will match here. But what I put here is half of 16 squared, which actually is, I added on 64. Okay, so I want you to know what you're adding on there actually, but this is the factored form now. Okay, so this one's going to have a fraction, and yes, we're going to have several fractions today to work with. This is 5 halves. Quantity squared goes there. It's x squared plus 5x plus 25 fourths. Okay, if I get the pen to stay still there. Okay, and then the factored form is x plus 5 halves quantity squared. In this one, 9 halves squared goes in that blank, which would give us this polynomial, this perfect square trinomial plus 81 fourths, which is factorable to x minus 9 halves quantity squared. All right, now that was notes. Sometimes I think if you're doing it, you may have put the number in as opposed to writing these things, but I want you to keep remembering what you're doing, where you got it from. Okay, so now we're going to do completing a square to solve any quadratic. First, you want to make sure that the coefficient of x squared is 1. If it's not, you have to divide by whatever that number is till you get it to be a 1 there. Okay? Write an equation in the form x squared plus bx, add blanks to each side, and then add half of b squared to each side. Factor as a binomial and take the square root of both sides to solve it. So here's what we got to do. I'm going to see if I can blow this mess up. I don't like how tiny it is. Okay, that's about as big as I can make it without making it crazy. Well, that looked cruddy. That's okay. All right, Lisa's bigger. So what I'm going to do is I'm going to rewrite the first two terms, the ax squared plus bx part. I'm going to add on a blank. I'm going to write my equal sign, and since that 4 wasn't the correct number, I'm going to subtract from both sides, and I'm going to add a blank on the other side because I added I'm going to be adding something on the left. I must add something to the right. All right, so this is how you set it up. I got the 4 over to the basically over to the other side. I don't like saying it like that because you're really just subtracting 4 from both sides. And then you add in a blank on both sides. Next, you try to rewrite this as a perfect square trinomial by putting in the blank half of 12 squared, which would be 6 squared. So you're doing that to both sides. What you add to one side, you must add to the other. The golden rule of algebra. 2 on to one side, what you do to the other. Okay, so then you're going to factor this to x plus 6 quantity squared. You're going to evaluate negative 4 plus 36, which is 32. And now you can take the square root of both sides and solve it like the first problems we started off with today. We will simplify the radical and subtract 6, so negative 6 plus or minus 32 is 16 times 2, so it's 4 root 2, and that is the end. We cannot go any further. Yes, Haley? You can write 36, sure. No, doesn't matter to me. I'm just trying to remind, again, yeah, 36 in those blanks is great. Okay, 10, x squared minus 6x plus blank equals negative 6 plus blank. I subtract the 6 from both sides and put in my blanks. Half of 6 is 3, so we're going to put 3 squared. If you just want to put 9 in, that's great, no problem. X minus 3 quantity squared is the factored form on the left. Negative 6 plus 9 is 3. We're going to take the square root of both sides. So we got plus or minus the square root of 3. Then we'll add 3. 3 plus or minus the square root of 3. Number 11 is kind of set up already, except I'm going to put in my blanks. Half of 2 is 1, and 1 squared is 1. You don't have to write it 1 squared. It factors to x plus 1 quantity squared, and on the right you get 5 plus 1, which is 6. Take the square root of both sides. I have plus or minus the square root of 6, and then I subtract 1, negative 1, plus or minus the square root of 6. Now, just to clarify, I want them written like this. I really do not want you to write minus 6 afterwards. Okay, so get used to putting that, whatever you're adding or subtracting, in the front of what you took the square root of. All right, and it's kind of going to follow the format that we'll be in when we start doing quadratic formula, and I think you'll find it a little bit easier. Plus, you can make mistakes, especially if you type stuff on the calculator, if you put it in the back, because you don't, then you got to close the parentheses and all kinds of reasons why it's better this way. Now, you have 12, 13, and 14. I want you to go try 12 right now on your own, please. 13 and 14, and then we're going to check. Yes, Scott. Yep. Well, for the type of problems we're doing right now, yes. I wanted to insert a page. For some reason, I don't have pictures of those. I'll put them in here right now. Okay, I'm going to go real quick, see how we did. How we do? 5 plus or minus 2 square roots of 3 for number 12. Next one. plus or minus 6 plus or minus 3i for number 13. Okay then, what do we want to talk about here? Square root of negative 9 is 3i. That's page 280, the lesson no one did. Because it's square root of a negative has an I. All the answers to anything that's square root of a negative will have I in them. Brooke, you did it.
Yeah.
Okay. You better know about I, because we have done the lesson on I. Okay, so this one we should have had another I answer. X plus 4 quantity squared. What's that? Negative. Was this an I one? Yeah. Did I add right? Negative 22 plus 16. I just seem to add in my head right now. All right, so then we would have subtracted to be negative 4 plus or minus I times the square root of 6. Got to pull out your I. Okay. Very good. I think some people need to practice things with I in them. It will be on the next quiz. We have one more quiz before unit test. Yes. Sure. So are we okay with where I got here? Did I skip too much? Okay. No? All right. All right now, 15. Uh-oh. Leading coefficient is not 1. So we have to divide every term by 2. That gives us some fractions. And yes, we're going to keep everything fractions. We're going to subtract that 5 halves and add a blank on the right. What would half of 7 halves be? 7/4. You're right. Half of a half is a fourth. Half of 7 halves is 7/4, and so we're adding 7/4 squared to both sides, which is 49/16. The left side factors to x plus 7/4 quantity squared. Adding negative 5 halves and 49/16, you have the fancy calculators. You can type negative 5 divided by 2 plus 49 divided by 16. You can hit math, enter, and you will get the fraction. I'm going to do it without it. Okay, that's negative 40 plus 49, and that was faster for me than typing it on a calculator. Multiply top and bottom by 8. Not that bad. Negative 40 plus 49 is 9. You get 9/16. You then take the square root of both sides, plus or minus. The square root of 9/16 is 3/4. That's why we've already done these things, radicals of square roots of fractions and all that stuff. We then subtract the 7/4. So we have negative 7/4 plus or minus 3/4. Well, one of those answers is going to be negative 4/4, which is negative 1. So x is negative 1 is one solution. The other answer is going to be negative 7/4 minus 3/4, which is negative 10/4, and that's negative 5 halves. Those are our two solutions. This is your answers need to be these answers. They have to be finished and they have to be simplified and reduced fractions. Okay. We got to deal with fractions, guys. All right, we're dividing by 2 again on the next one. We got x squared plus 3x plus blank equals 7 halves plus blank. half of 3. 3 halves squared goes in the blank, which is 9/4. The left factors to x plus 3 halves quantity squared. Multiply 2 top and bottom. We can do that one in our head. 14 plus 9 is 23/4. Take the square root of both sides. We're going to have the square root of 23 plus or minus the square root of 23 over 2. Square root of 4 is 2. I'll show you what I'm just doing that and simplifying it, and that's what it is. Then I subtract 3 halves. So it's going to be negative 3 halves plus or minus square root of 23 over 2. Okay? Anybody still need the page? All right, now what do we divide by? 3. Yeah. Okay, I like to show that. You're actually dividing the 0 by 3 too, but so we'll have x squared minus 2/3 x plus blank equals negative 12 divided by 3 would be negative 4. We'd have to add 4 to both sides. So we'll have 4 plus blank on the right. This one's not bad. We got half of a 2/3 is, what's half of 2/3? You have 2/3. One of them, 1/3 is half. No, you needed to just, I know, it's, what's half of, 2/8 and 2/9, 1/9. Yeah, that's, all right. It's all right. All right, factor this guy, x minus 1/3 quantity squared. Now, I'm going to go ahead and, you guys have been liking that, I think, to evaluate that right away. What's 1/3 squared? That's 1/9. So if you wrote 4 1/9 here, now I would want to change that. I could make it into an improper fraction. That'd be 37/9 plus or minus the square root of 37/9. Now, that's the square root of 37 over 9, so I might as well take this. Never mind. You mind if I do more than one step? What I'm doing is saying, what's the square root of 37? Well, it's just square root of 37. Square root of 9 is 3. So that would be on the bottom. And then I have to add the third. So it's just going to be 1/3 plus or minus the square root of 37/3. These are exact answers. And the kind of the last one actually is giving us a little break because all of those numbers are divisible by 5. And I don't get any fractions. But then I just do my completing the square, subtract 15, and then add a blank on both sides. What goes in the blank is just 1. And I get x minus 1 quantity squared equals negative 14. Why? No, I did something dumb. I divided by 2 on the last one. I was just say some numbers off here. Ay. Guys, what's 30 divided by 5? 6. Hello. I know. Oh, I just got to fix the 15. That's the only thing. Kind of screwed up, though. Okay. Yeah, I've made worse mistakes than that. All right, subtract 6 because we got negative 5. Are we good? X minus 1 quantity squared equals negative 5 now? You all know why it should have been 6, right? Divided by 5, and I don't know how I made that brain cramp. I didn't want to say what never mind. X minus 1 equals plus or minus I times the square root of 5. Pull out your I. And, so painful. Okay, 1 plus or minus I times the square root of 5 is our answer. Are you okay now? I screwed you all up. I have too much eraser issues. I know, right? My apologies. I have some erasers. Yeah, I have big erasers. All right, one more thing. Well, here's the point of this. Why would we even want to do this so much? Well, because we just have to try every method of solving quadratics. That's because we're in the quadratic unit. Y equals A times X minus H quantity squared plus K. There is a real good reason to want to do this if we want to graph a parabola. Perfect. Completing the square can get us vertex form. From standard form to vertex form. Okay, so here's the deal. We're going to complete the square, but now we are going to do everything on one side. Because we don't really, we want to stay Y equals, so it looks like this format. So you're going to bring that 11 and just kind of put them outside here. I'll kind of group these for you. But now, wait a minute, guys. Let's think about it. If I'm going to add something, what could I do to counteract it or make it seem like it didn't actually happen? Subtract it. Okay? So, good job. So I heard several of you say that. So what happens now is instead of we're adding the same thing to both sides of an equal sign, we're going to do add and subtract the same amount in two places on one side of the thing. Okay. All right. Why would we're going to get it in this format? So you watch the magic, all right? It's kind of cool, actually, because it gets it there really quick. So we do our process of completing the square. We take, this is your b value. Half of that squared goes here. So 4 squared goes there. You also got to subtract it, though. Okay? So now we're going to rewrite this as our perfect square, x minus 4 quantity squared. And then if you want to write a 16 instead of a 4 squared, that's fine. 11 minus 16 would be not plus, but minus 5. And look, there you go, vertex form. So the vertex is for -5 for that parabola. We're going to be ready to graph now. Wasn't that bad, right? Okay, let's try this one. I'm just going to bring it down here. Y equals, I'm going to put the ax squared minus bx part plus a blank. I'm going to move that c that's not the right number outside and subtract a blank. Okay. Half of the b term would be 2. 2 squared is 4, so we're adding 4 and taking away 4. Factor the trinomial x minus 2 quantity squared. 8 minus 4 is positive 4. And there's that vertex is at 2, 4. I heard someone say, I did it. Okay. Good. How about how you do it on the next one? The numbers a little. Go for it. Try number 21. The vertex, we are not graphing that one. Now you see why. How we do? -6, -39 for your vertex. Okay, complete the square is done now. You know your assignment. I'm about to hand it to you. It is on this book page, 288, and I have typed it up for you.